Okay, my dear student, this class for class 9. Chapter number 5, state of matter and pressure. My today's topic is, my dear student, Pascal's law. Okay. At first, I'm going to discuss about the statement of Pascal's law, then mathematical analysis of Pascal's law, and after that, I'm going to solve a creative question on the basis of this Pascal's law. First of all, my dear student, the statement of Pascal's law. Just write down the statement of Pascal's law with me, and then we're going to learn about Pascal's law in detail. So, statement of Pascal's law. Statement of Pascal's law. When pressure is applied, when pressure is applied on a closed container, having some liquid inside it. When pressure is applied on a closed container having some liquid inside it, then that pressure does not diminish and acting equally in all sides of the container, and acting equally in all sides of the container. And acting equally in all sides of the container, my dear student. So this is the statement of Pascal's law. And the statement is here: when pressure is applied on a closed container having some liquid inside it. So at first I'm going to take a closed container, my dear student, and then I'm going to apply pressure on it. Then say to Pascal that applied pressure does not diminish. I repeat, that applied pressure does not decrease or diminished. Okay, and it's acting equally. It's acting equally. It's circulating equally in all sides of the container. What does it mean? Your applied pressure will equal to your obtained pressure inside a container having closed container, having some liquid. Suppose, my dear student, you are going to take a closed container having a liquid, and you're going to apply a pressure that is equal to, suppose, 50 Pascal pressure. So if you apply 50 Pascal pressure, then you see that that amount of pressure does not diminish, does not degrade, does not decrease. Okay, and this pressure is acting equally. That means 50 Pascal pressure is acting equally in all sides of the container. 50 Pascal pressure is acting equally in all sides of the container. So what is the basic outcome of this law? The basic outcome of this law is your applied pressure will equal to the output pressure or obtained pressure or executing pressure. Okay. On the basis of this statement, a special type of instrument is designed. That instrument is called hydraulic press. My dear student, that instrument is called what? That instrument is called hydraulic press. So my dear student, hydraulic press. In hydraulic press, my dear student, it's a closed container having two opening mouth. It's a closed container having two opening mouth and can contain some liquid. And the common example of the liquid is water. There's two opening mouth. You see that one is small mouth, another is large mouth. So this two mouth is closed by cylinder, by piston. This two mouth is closed by piston. So this two mouth is closed by piston, having some water inside it. So having some water inside it, okay? It has some water in it. Now, my dear student, I'm going to apply pressure. So at first, I'm going to say about the piston. What is called piston? Piston is just like valve. Valve is that substance which is indicate the one-way movement of liquid. Suppose, for example, you know that you have some valve and I have also some valve in my vein. Okay, in that particular vein, you know that blood carry from outer organs to the heart. Okay, so vein can carry blood from outer organ to heart. And at that at that vein, there are so many valves there, and that so many valves ensure that the one-way movement of blood. I repeat, my dear student, that that so many valves ensure that the one-way movement of blood, because you see that blood can carry the vein into gravity, against the gravity, and it's a very tough movement against the gravity. And because of this against gravity movement, valve ensure that one-way movement of blood. Okay, so just like this here, these two valve or these two piston can ensure that the water can move in one-way direction, just in one particular path. And my dear student, this piston is known as small piston or small valve. And this piston is known as large piston or large valve. My student, or large valve. And then the applied pressure on the small piston, my dear student, suppose it is P1. And the obtained pressure at the large piston, this will be called to what? This will be called to P2. My dear student, according to this Pascal's law, I can say that the applied pressure does not diminish inside the liquid container. Inside the container. I repeat, my dear student, the applied pressure does not diminish inside the container. So in this particular container, you see that the applied pressure here and this applied pressure here, it does not diminish. It does not shorten, my dear student. It does not diminish. It does not shorten. Okay. And this pressure is acting vertically. This pressure is acting perpendicularly and also equally in all sides of the container. So what does it mean? It indicates that applied pressure P1 will equal to applied pressure P2. I repeat, my dear student, it indicates that applied pressure P1 will equal to applied pressure P2. So we can say that from here, pressure P1 will equal to what? Pressure P2. Here P1 is the applied pressure at the small piston, and here P2 is the obtained pressure at the large piston. Now, my dear student, suppose at the case of small piston, the applied force is F1 and area of cross section is A1. I repeat, my dear student, at the case of small piston end, here applied force is F1 and in this particular case, area of cross section is A1. I repeat, my dear student, in this particular case, area of cross section is A1. Again, my dear student, the force that is acting at the large piston, that is F2. And in this area, in this case, area is A2. Any one of you, my dear student, any question? My dear student, any one of you, any question here? My dear student, any one of you, any question, my dear student?
Can you explain the statement of Pascal's law, sir, shortly again, sir? Very shortly, sir.
Okay, very good, no problem. The basic outcome of this Pascal's law is that, my dear student, input pressure in a closed container having some liquid will be called to output pressure. You see, my dear student, in this particular system, the input pressure is P1. The input pressure is P1 and the output pressure is P2. The basic outcome of this law is the input pressure will be equal to the output pressure. But there is a condition here. That condition is having some liquid in a closed container. Okay, my dear student, is it clear to you? My dear student,
Yes.
is it clear to you? Any one of you? Any confusion here, my dear student?
No, sir.
Any one of you? Any confusion here? Okay, very good. Now, my dear student, we can say that here, in the case of pressure P1 will be equal to F1 divided by A1. And again, my dear student, pressure P2 will equal to what? Pressure P2 will equal to here F2 divided by A2. Now, I'm going to put the force in one side and area of cross section in another side, my dear student. I'm going to put the force in one side and then area of cross section in another side. That's why I'm going to replace these two quantities with each other. I repeat, that's why I'm going to replace these two quantities with each other, okay? And then we obtain that, we get that here, A2 by A1 will equal to what? Will equal to here, F2 by F1. And A2 by A1 will equal to what? Will equal to here, F2 by F1. Or finally, you can say that F2 by F1 will equal to, this is A2 by A1. Okay, my dear student. So this is nothing but the mathematical equation of Pascal's law. I repeat, my dear student, this is nothing but the mathematical equation of Pascal's law. F2 is the obtained force in large piston. F1 is the applied force in small piston. A2 is the area of cross section for the case of large piston, and A1 is the area of cross section for the case of small piston. So here A1 is the area in the case of which one? In the case of small piston. Now, my dear students, you know that piston is just like a valve, just like a circular valve. Okay, so since it is just like a circular valve, that's why I can say that this circular valve having a area, and that area will equal to pi into r square. My dear student, that area will equal to what? That area will equal to pi into r square. Now, since area A will equal to pi into r square, so put down this value of area, then you get F2 by F1, it will equal to what? Pi into r2 square divided by here pi into r1 square. So you see that pi will cancel out from both sides, from numerator and denominator. My dear student, pi will cancel out from both sides, from numerator and denominator, okay? And then you get this equation. This is F2 by F1. It will equal to here R2 square divided by R1 square, my dear student. It will equal to R2 square divided by R1 square, okay? So this is the equation of Pascal's law. So these are the two equations for the case of Pascal's law, my dear students. Now, any confusion among you up to this discussion, my dear student? Up to this discussion point, up to this point, any one of you, my dear student, and confusion here?
Sir.
And confusion, my dear student? Any one of you? Any confusion here, my dear student? Any one of you, my dear student, and confusion? Okay. So if you have no confusion, then I'm going to start a creative question on the basis of this Pascal's law, my dear student. So if you have no confusion, then I'm going to start a creative question, okay, on the basis of this Pascal's law, okay? So let's solve a creative question, my dear student. Let's solve a mathematical problem. So, a creative question on the basis of this statement, on the basis of this Pascal's law. So my dear student, creative question. Again, this is a hydraulic press, my dear student. Again, this is a hydraulic press, small piston end, and this is the large piston end. Force is F1, we call to suppose 2 Newton. Area of cross section A1 equal to suppose 0.5 meter square. Force F2 will equal to what? Area of cross section A2 will equal to suppose 2 meter square. So these are the information, my dear student, available in STEM. So these are the information. Okay. So this hydraulic press having some water in it. So the liquid is here, water. Now, my dear student, you see that in the stem there are two pistons. One is small piston, and you see that another is large piston. In the small piston end, the applied force is F1 equal to 2 Newton. I repeat, in the small piston end, the applied force is F1 equal to 2 Newton. And then, my dear student, area of cross section A1 will equal to 0.5 meter square. Area of cross section A1 equal to what? It will equal to here 0.5 meter square. And again, in the case of large piston, the force is F2. And here, area of cross section A2 will equal to 2 meter square. And here, area of cross section A2 equal to 2 meter square, by the student. Now, my first question, question number C. Calculate the value of F2. And then question number D. Draw the graph of F2 versus F1 for different values of F1. My student, draw the graph of F2 versus F1 for different values of F1. Okay, my student. So these are the two mathematical questions on the basis of this step. I repeat, my student, these are the two mathematical questions on the basis of this step. Okay, the first question is here, calculate the value of F2 versus F1. So this is the first question. And the second question is here, draw the graph of F2 versus F1 for different values of F1. My dear student, draw the graph of F2 versus F1 for different values. You are taking the different value here of F1. Okay, now I'm going to solve question number C. You see that, my dear student, for the case of Pascal's law, here all of the quantities, all of the physical quantities given here, okay, except F2. So it's very easy to find out the value of F2, my dear student. So it's very easy to find out the value of F2 by using which law? By using the mathematical function of Pascal's law. You know that Pascal's law's mathematical function is F2 by F1 will equal to what? Will equal to A2 by A1. So, my dear student, what's the value of F2? It will equal to A2 by A1, and this is multiplied by F1. Okay. So now put down the values of F2. This is 2, F1, so A1, this is 0.5 and multiplied by 2. So what is the force F2 at the large piston end? My dear student, what is the force F2 at the large piston end? Find out the force F2 at the large piston end, my dear student.
8 Newton.
8 Newton.
8 Newton. 8 Newton. Very good. Any confusion, any one of you, my dear student? Any confusion here?
No,
Any
sir.
one of you, my dear student? Any one of you? Any confusion here, my dear student?
No, sir.
And confusion? Yes, very good. Okay. Now, before discussing your starting point, question number D, my dear student, I'm going to discuss two things. First of all, I'm going to draw the graph F2 versus F1. So, in between F2 versus F1, which one is independent? From this given question, it's very clear to me that the independent function is F1. I can vary F1, and then I'm going to find out the corresponding value of F2 with respect to that F1. I'm going to find out the corresponding value of F2 with that value of F1. Okay, so first point is this. And the second point is here by the student. To draw the graph, we should consider minimum 3 points. I repeat, we should consider minimum 3 points. Okay, what should be the first point? First point should be the origin point. So at which point this graph starts for? Okay, this point is known as the origin point by the student. When you want to draw the graph, you must mention that from which is the origin point, which is the starting point of a graph. So you must mention this point, okay, firstly. And then by the student, if it is a straight line, you'll take minimum 2 points. If it is curve, you'll take at least 3 points. Okay, so to draw a graph, I think which one is the most safest path? The most safest path, you must consider at least 3 corresponding points, F1 and F2. Okay, now my student, we're going to draw the graph and it will make your concept clear. Question number D. You see that at first I'm going to find out the starting point of the graph, the origin point of the graph. How can I find out the starting point? Suppose by the student, if the applied force at the small piston end F1 is 0, if the applied force at the small piston end F1 is 0, so when F1 is 0, then I'm going to find out what should be the value of F2. So for F1 equal to 0 Newton, then F2 will equal to what? By the student, if you want to find out the value of F2 only from this equation, then what would be the equation of F2 by the student? Then what would be the equation of F2? If you want to find out the value of F2 only, F2 will equal to, you can say that A2 by A1 multiplied by F1. I repeat, my student, F2 will equal to A2 by A1, and this is multiplied by F1. Okay, and this is multiplied by which quantity? This is multiplied by F1. Okay, so this is what? This is A2 by A1, and this is multiplied by F1. Okay, my student. So A2 equal to here 2 Newton, 2 meters square. A1 equal to 0.5 meters square. And what is the value of
Sir,
F1?
F1 equal to কি লিখেছেন?
F1 equal to 2 Newton, my student. F1 equal to 2 Newton. Okay. So F1 equal to 2 Newton. But in this particular case, F1 equal to what? 0 Newton. My student. In this particular case, F1 equal to 0 Newton. So when F1 equal to 0 Newton, then what would be the value of F2? This is also 0 Newton. This gives me the idea about the origin point, about the starting point of the graph. The concept is clear to you by the student? This gives you the idea about the origin point, about the starting point by the student. So it gives you the idea about starting point by the student. Is it clear to you?
Yes, sir.
Yes, sir.
Okay, then by the student, you already consider F1 equal to 2 Newton.
Sir, F1 equal to 0 Newton কেন ধরলাম?
Very good question by the student. To draw a graph, at first you are going to mention the starting point by the student. At first you are going to mention the starting point or origin point. You see that, my dear student, in this particular case, if F1 equal to 0, then I think it gives you the idea about the starting point of the graph. When F1 equal to 0, then F2 equal to 0. So this is the starting point of the graph. Is it clear to you, my dear student? So to draw a graph,
Yes, sir.
you must mention one condition. That is, what would be the starting point of the graph? Okay, my student, from which point this graph starts its journey? This point is known as starting point. This point is known as origin point. Okay, my student, this point is known as starting point or origin point. Okay? Any confusion, my student? Any confusion of you?
No, sir.
Okay. Then
No, sir.
you already know that from question number C. For F1 equal to 2 Newton, then my student F2 will equal to 8 Newton. We obtain this from answer number C, my student. We get this from answer number C. Now I consider 2 for F1, 0 for F1. Then next point I should consider 4. I repeat, my student, the next point I should consider 4. Because to draw a graph, my student, at least we should consider 3 points. I repeat, my student, at least we should consider 3 points. Okay, this is the minimum point to know the shape of the graph. Okay, so for the case of, my student, for the case of F1 equal to, suppose 4 Newton, then what would be the value of F2? F2 will equal to, my student, again A2 by A1 multiplied by F1. So A2 equal to 2 Newton divided by A1 equal to 0.5 Newton and F1 is equal to 2. No. Is it F1 equal to 2? No. F1 equal to 4. So what is the value of F2, my student, in terms of Newton?
So
16.
16 Newton. Very good. So I got 3 set of points here, my student. I got 3 set of points here. Okay. So by using this 3 set of points, I can draw the graph. We can draw the graph very easily, my student. Okay. So let's draw the graph by using these 3 corresponding points. So let's draw the graph, my student. You see that this is the side for F1 counted as a Newton. This is the side for F2, calculated as a Newton. This is the origin point. This is 0, 0. You see that the value of F1 is 0, 2, 4, just 3 points. So I'll just consider here, this is 2 and this is 4, my student. Because there are only 3 points here, 0, 2, 4. So I just consider here, second point is 2 Newton point and third point is 4 Newton point, my dear student. And then you see that for the case of value of F2, 8, 16. Suppose second point is 8 and third point is here 16, my dear student. Suppose second point is 8 and third point is here 16. And then we're going to draw the corresponding lines here, the parallel corresponding lines here, just like the graph shape of the graph. Okay, then just like the shape of the graph, my student, the corresponding lines, just like shape of the graph. Okay, and then you see that, my student, now the first point is 0, 0 point. What, my student? The first point is here 0, 0 point. So since it's the first point, that is 0, 0 point. So this should be the first point, my student. So this should be the first point. Okay, my student. So this should be the first point. And you see that, my student, the second point is here 2, 8 Newton. F1 equal to 2, F2 equal to 8. So second point is corresponding to 8 point. So this is the 2 point and 8 point, my dear student. The third point is here 4, 16 point. I repeat, the third point is here 4, 16 point. Okay, so 4, for the case of 16 point. Then add these lines, my student, add these points. So if you add those points, then you get, I think this is a straight line. I think this is a straight line, suppose up to point A. So finally, you can say that if we draw the graph, F2 versus F1 for the different values of F1, I repeat, if you draw the graph F2 versus F1 for the different values of F1, then we should say that the graph is a straight line, and this straight line passing through the origin. I repeat, my dear student, the graph is a straight line, and this straight line passing through the origin. Any one of you, my dear student, any confusion about this discussion, about this class? My dear student, any confusion here?
No, sir.
Any one of you, my dear student, any confusion here?
No, sir.
Okay, very good.